Good afternoon, everybody, and welcome to CPG Europe's Windows and Facades Coffee Chat series. Today's presentation should last around 12 minutes or so, followed by a Q&A session at the end of the webinar. Please feel free to ask questions throughout today's presentation, and our specification manager, Rob Halliwell, who is leading today's webinar, will be all too happy to answer them at the end. So without further ado, I shall hand you over to Rob.
Very good afternoon to you all. And the first topic in this series is membranes and tapes used within the facade for proofing works. Really what we need to do is to distinguish the difference between tapes and membranes. So to start with, in the context of the built environment, this is the definition of a membrane. Membranes are used in this context to provide a barrier or to prevent something getting in or out, but are often required to be diffusible, allowing vapor or other gases to pass but not liquids. Conversely, some membranes are used to prevent the transfer or diffusion of gases. It very much depends on the application involved. Membranes do not and cannot provide a barrier or insulation against fire, but where relevant buildings are concerned, membranes must achieve a minimum reaction to fire. Membranes are sometimes backed with a high-strength water or moisture-resistant self-adhesive. Some membranes require a separate paste adhesive or a tape before they can be applied to provide a permanent bond. Some membranes are equipped with preformed profile gaskets on the leading edge, but require an adhesive to bond the trailing edge. If a paste adhesive is required, it should be compatible with common substrates for ease of use, and a responsible manufacturer provides a range of alternative adhesives and primers to deal with difficult circumstances and varying substrates. Membranes are often required to provide appropriate UV resistance and always have non-degrading attributes. Once applied, membranes are left permanently in situ and should last as long as the building or the substrates to which they are applied. Some membranes are supplied as furled sheet materials on a log. All slit to size membranes start off life as a much wider log and are cut into various widths to suit different construction details. Membranes that are used internally and externally. Internal membranes, often structural monolithic membranes, are applied to the structure to create a separation layer that is air and vapor tight. A monolithic air and vapor membrane provides a proofing layer to the structure and are sealed with a tape and often a system adhesive for optimized functionality. Proprietary internal window, door and curtain wall membranes are also used, often to provide an independent perimeter seal to the interface between the frame and the wall to provide a properly calibrated air and vapor seal. Membranes applied to the internal construction reveal are linked to the primary monolithic air and vapor membrane, and the two work together to form what is commonly known as the vapor control layer. External membranes, again, sometimes monolithic, such as a breather membrane, are applied to the external sheath structure to create a separation layer that is air and water tight, but vapor open. They are breathable, allowing water vapor to escape, but not liquids to pass. Monolithic breather membranes provide a proofing layer to the structure and are sealed with the tape for optimized functionality. In construction joints and glazing perimeters, proprietary slit width membranes may be used to seal the construction joint, such as between the sheathing boards and the concrete slab edge or columns. Tapes may also be used for this application, subject to their width not exceeding 150 millimeters. Tapes provide an air and watertight solution that is often more cost effective, but equally as high in quality and performance as a membrane for the same application. Proprietary external window, door and curtain walling membranes are used to provide an independent perimeter seal to the interface to provide an air and watertight but vapor open seal to the tolerance gap between the frame and the backing wall. External perimeter sealing membranes are an initial but becoming secondary seal only, and are usually only required when the glazing system is applied before the insulation and cladding layers. Membranes that are applied to the glazing perimeter are linked to the primary monolithic breather membrane, and the two work together to form an air and watertight but breathable secondary layer to the structure. External perimeter sealing membranes are not required when windows are installed into a completed traditional brick or block or cavity wall or a similar arrangement. Tapes. Tapes are used in this context to provide a barrier to prevent something getting in or out. Tapes are also used to join or seal junctions as standalone items, or are used in conjunction with proprietary membranes. In the built environment, tapes are almost always backed with a high-strength water or moisture-resistant self-adhesive. Tapes do not require or need to use a separate adhesive before it can be applied. Once applied, tapes are left permanently in situ and again will last as long as the building or the substrate to which they are applied. In the context of the built environment, tapes are restricted to a maximum width of 150 millimeters. Applications requiring a sealing solution, such as a tape above 150 millimeters, would normally require a membrane in substitution as an alternative. Tapes such as expanding impregnated foam tapes like Gilbert Comproband and other familiar variants will be dealt with in another topic in this series. For now, we'll focus on tapes used in proofing works. Tapes used externally on the cold side of the wall should be particularly robust. Tapes must be able to demonstrate resistance to liquid water penetration, have resistance to UV degradation in cases of prolonged exposure, and be airtight when required. Tape should be compatible with common substrates and be malleable enough to conform to contours, angles, and relatively uneven or rough surfaces. Tapes applied to some porous and non-porous surfaces may require a primer. A primer is almost always required when the sealing or bonding application requires a bridge over a known barrier to adhesion, such as poorly applied silicone-based sealants. Tapes can often be applied at very low temperatures, i.e. below 5 degrees centigrade, with the use of a primer. Once applied, tapes should not perish in extreme weather and should resist in-surface temperature ranges from -degrees up to a little below boiling point. Tapes used internally may be seemingly less robust, but should be of equal high quality as an external tape. The tape again must be able to demonstrate some resistance to moisture, but not liquid, and should be vapor and airtight where required. Internal tapes may have less UV resistance in cases of prolonged exposure. Tape should have compatibility with substrates and be malleable enough to conform to contours, angles, and relatively uneven surfaces. These tapes are also often applied to porous and non-porous surfaces and may require a primer. Once again, internal tapes can also be applied with the use of a primer in lower temperatures. But once applied, they shouldn't perish in extreme weather and should resist in-surface temperature ranges to the same level as an external tape. Some common uses for internal tapes are to seal or join overlapping seams of monolithic coverings, to bond or stick perimeters or loose edges of monolithic coverings to a substrate, to repair or patch accidental damage on a monolithic membrane, and Ilbruck tapes are not substitutes for proprietary internal or external window, door, or curtain walling perimeter sealing membranes. Here we can see how the internal air and vapor tight line is formed with the primary vapor barrier membrane interfacing with the internal window perimeter sealing membrane. Vapor control barrier membranes are monolithic covering to provide the separation layer and are applied to the internal framing only. Structural coverings such as this are not intended for small junctions such as internal window perimeters, and they should be sealed independently to the structure with the use of a proprietary tape and adhesive system. An additional and properly calibrated independent membrane is applied to the internal window perimeter, which then laps onto the primary vapor barrier membrane, or vice versa. In respect of their vapor resistance, the two membranes act to form a vapor control layer, but are configured to provide appropriate vapor resistance applicable to their individual primary function and principal application. In a framed and sheathed wall, There are a variety of tapes and membrane seals to be applied to the external backing wall, because this is where so many of the construction interfaces converge. Application 1 is a board-to-board and board-to-structure interface. Proprietary air and weather type tapes are often used in this application, and sometimes membranes. It very much depends on whether a specific reaction to fire is required or whether costs need to be considered. Application 2 is the primary glazing perimeter membrane. This needs to be airtight and weathertight, but breathable. This is an initial becoming secondary seal once the cladding layers have been applied. These membranes should have appropriate UV resistance and, depending on the type of building classification, an appropriate reaction to fire. Application 3 is a structural protection layer, i.e. a monolithic breather membrane, which needs to be weathertight and vapor open with appropriate UV resistance, and again, depending on the type of building classification, an appropriate reaction to fire. Application 4 is the breather membrane overlapping seams to breather membrane perimeter to glazing membrane sealing application. Proprietary air and weathertight tapes will be used here to seal one to the other and to itself. Application 5 is a special type of sealant which can be used in certain circumstances for difficult or hard to seal items such as base plates, brackets, and so on and so forth, not within the scope of this presentation. So, for the avoidance of doubt, uses and attributes may be similar, but materials are different. Tapes are used in conjunction with a membrane or on their own. Tapes are often a necessary component to enable the use of a larger membrane. Tapes can be used instead of a membrane subject to width restrictions and the application in question. Membranes are used in widths down to 70 millimeters, but typically wider than 150. Membranes are often very monolithic in nature and applied to other surfaces. To simplify, tapes are a barrier with no diffusible properties. Membranes are often required to be diffusible and sometimes not. Do we have any questions?
Thanks very much for that presentation, Rob. I can't see any questions in the question box at the moment, and there isn't any messages in the chat feature. If nobody has any questions at the moment, we can wrap up the session there. But please feel free to reach out to Rob directly by email or on LinkedIn, and he'll be more than happy to answer any questions that you may have. Let's just see. I think we've just seen a question popped up. Okay. Okay. Rob, can you see the question that we've got here?
Yeah, what are the other dates? So the next one is in a fortnight, and that is the awkward truth about fire membranes. And then following that, a fortnight later, so from memory, we've got the 20, no, I think it's the 4th and then the 18th of February are the next in this series at this time.
And we'll be sending invites out in due course for both those events. So please keep an eye out on your email inboxes or our promotions on LinkedIn for those for parts 2 and 3 to this coffee chat series.
Yes, so the purpose of today is really to try and distinguish the difference between materials, not too technical. We get into the more nitty gritty as we progress. So hopefully see you all again. So is that another question that's just popped up?
Yeah, we've got another one here.
Which I can't see, unfortunately.
Okay, it says, projects are quite demanding about fire performance. It should be better than Class E. What membrane do you have to achieve this requirement?
Well, we have a couple of options here, and again, it depends on the application. Specifically, the topic of fire is dealt with in the next webinar. Is this relating to? I'm sorry, I can't see who is asking the question.
George Talon.
George, okay. Right, do you have a specific project in mind? Would you like to have a discussion with me so I can help you? I mean, the short answer is that we have Class B breather membranes and Class B perimeter sealing membranes. So respectively, two versions of a product that we call ME010, and the other is another product called ME480, but very much depends on the applications involved as to which is the right product.
And we have one last question from Tim. Can a copy of the presentation be circulated for use in Toolbox Talks? Yeah, absolutely. We will get that across to you, Tim. And I think that's everything else. But yeah, please feel free to reach out to Rob directly at rob.halliwell@cpg-europe.com if you do have any more questions about today's presentation. Thank you very much.